You're back. Well, this is part 2. How to add, subtract factors when fractions. Remember, smile. Okay, let's get into this. Okay, so what do we do with this problem? We have the same value on the bottom, basically, right? I mean, we've both got like a 4x. We've got a 4x and a 3y and a 3y. But we can't subtract them? No, we can't. Because they're still different. We have to prove that this side is equal to that side. And maybe it is, maybe it's not. If it's not, we have to make them both the same on the bottom. Okay, let's do this. This side is written as something x minus something y, right? So let's also make this side equals something x minus something y, or plus y. So, okay, this is just going to be the barrier. Until they're equal, they cannot cross. Somewhere down here, we're going to bring some kind of bridge. Yeah, that looks stable. Okay, all right, so we're going to have minus 4x plus 3y. Okay, well, they look the same, but the thing is, 4x over here is now negative, and negative 3y over here is positive. So that means that the only thing that's different about this side is that it's the negative version of what's on this side. So that means that if we were to take out a negative from this, or divide this by -1, we would get this. So let's do that. I'm going to factor out a -1, which makes this negative 4x, 4x. Ooh, that's looking good. Look, 4x, 4x. Yeah, that's what we want. Okay, so this 3y, if we divide that by -1, it's going to become 3y. Look at that. They're the same. Okay, cool. This is where we want to be. So that means that the only difference between this side and this side is -1. Okay, cool. Well, now they can unite. Yay! Can't see that as a smiley face. All right, so if the only thing that is different between this side and this side is -1, let's just multiply this side by -1. So let's do that right here. Let's do -1 times -1. No, that's not what I meant. Let's multiply it by -1. No, I did mean multiply by -1 over -1. Because if you just multiply it by -1, you would be changing it. We have to do the same on top and bottom. Okay, all right. So previously I proved that if you were to multiply all this by -1, it would be the same as this. So let's just change that. This bottom is now this. It's 4x minus 3y. Now the top, that's going to be different. But, so we've already figured out where this one goes. This goes in here, and it makes this guy all different. This -1, when we multiply to this side, it's going to make this positive, right? Because if you were to bring this -1 and put it there, you would be subtracting a negative thing. So the minus minus becomes positive. So this becomes positive, and we can keep it 4x plus y. And then we have 2y over 4x minus 3y. Okay, so now that they both have the same thing on the bottom, we can combine them. Let's make that nice and sturdy. Okay, so we have 2y plus 4x plus y over 4x minus 3y. Okay, so combine these two guys. And we get 3y. Well, let's start with x first. So 4x plus 3y over 4x minus 3y. And then that is our answer. Okay, more problems? Yes. Yes. Okay, all right. This one is the same idea, just a little bit different. We're not going to multiply one side by negative, but we're going to want the bottom to all be the same. So can you see what this problem is telling us? Do you remember perfect squares? Where if you multiply this, like a x plus y times x minus y, you get x squared minus y squared. So that's basically what we have here. We have 2u minus v, 2u plus v. And over here you have the squared version, right? 2u squared is 4x, 4u squared. V squared is v squared. Duh. Okay, so that means that this side is just missing this. And this side is just missing that. And this guy is all good. We don't need to change him at all. He's just happy over here. We're going to leave him alone. Okay, so that means we need to multiply this by that. So we'll do that. 3u over 2u minus v times 2u plus v over 2u plus v, and then minus this times that. 2 over 2u plus v times 2u minus v over 2u minus v. Okay. I'm just going to do the tops first because our goal is to have the whole thing on the bottom all the same. So let's just draw one big line. And then let's make sure to add in this last part. I almost forgot about that. But it's all over this. And then I'll just show you how this times that gets to that if you want. Okay, so we have 3u times 2u. That gives us 6u squared plus v times 3u, which is 3uv, minus 2 times u plus 2v, because minus becomes plus. Okay, so that's the combined top with this. Okay, so let me just show you this. 2u minus v times 2u plus v. Let's do the first, outside, inside, last. But first is going to be 2u times 2u. And then the outside is 2u plus v. Inside is going to be minus v times 2u. And then last is going to be minus v times v. So 2u squared, 2u times 2u is 4u squared, plus 2uv minus 2uv minus v squared. And since these are the plus and minus versions, they cancel out. So then we just have 4u squared minus v squared. Okay, so that's how this is that. Okay, so everything up here is a little bit messy. So let's make that neat. Let's put everything together that is the same. Oh, nothing is the same. Look, u squared, uv, u, v, v squared. How unique. They're all unique. This is the one downside about being unique. You can't find your like ones. Okay, well, it's still worth it being unique. All right, well, what we can do is we can at least order it in a different way. Nope. Even that's still pretty good because the only way that I would reorder it is alphabetically. You've got u squared, uv, u, v. Could we do anything else? Probably not. I mean, we could probably find something, but it probably wouldn't be that helpful. All right, moving on. That's basically it. It's helpful to, so just reviewing, when you see this guy and you see these two, this should be a hint that it's going to be some version of a perfect square, right? Because you have a squared minus another squared. And you have that guy minus that guy plus. And that's what you need to create a perfect square. All right, moving on. Okay, this guy is basically the same thing as the last one. The only thing that's different is this guy. You see how it's not, it's like a plus 2 here, right? This is not a minus 2. It's 2 minus a, which if you rewrote it would be minus a plus 2. Now the way to get it so that the a is positive is to take out a negative 1. So you'd have a minus 2. Okay, so let's just rewrite it. 1 over a plus 2 minus 4 over a minus 2. Right, because this minus made this plus negative. Plus a plus 14 over a squared minus 4. Okay. Again, this is going to be another perfect square. A squared minus 4 is the combination of a plus 2 times a minus 2. So this is going to need to have this multiplied to it, and this is going to need to have this multiplied to it. So let's do that. 1 over a plus 2 times a minus 2 minus 4 over a minus 2 times a plus 2 plus 2. And then a plus 14 over a squared minus 4, which is basically what these guys are going to be equal to. So let's combine the top all over one new denominator, which is a squared minus 4. A minus 2 minus 4a minus 8. Remember, because minus plus becomes a negative. Plus a plus 14. Okay, so let's just combine all the a's. Negative 3a, negative 2a. So we have negative 2a. Okay, negative 2, negative 10, plus 4. Cool. All right, and then one other thing we can do is this. Negative 2, a minus 2 over a squared minus 4. Wait, we can do one more thing. Remember, we know that the bottom is made up of a minus 2, a plus 2. So if we have a minus 2 here, we have one more thing we can do to simplify. Excuse me, I'm just going to squeeze you up there. We're going to rewrite the bottom to a minus 2 over a minus 2, a plus 2, and then cancel. So then the final version is 2 over a plus 2. All right, we're done. Cool. All right. Just like in my other videos, I ask if you have questions, let me know. Let me know what kind of questions do you want help on. Let me know what's like the perfect number of videos or a perfect number of problems in each video. Do you think these are too long, too short? Yeah, let me know what kind of things you like to see. And remember, have a good day and like and subscribe. All right, take care.